welcome back viewers. So, today we are going to go further and we are going to try to find the adjoint and what about the green function of the adjoint operator. So, this is the lecture number 12. So, today I will talk about that in the previous class we have studied the green functions and the adjoint operator. So, we know that I suppose I have a operator linear differential operator L, and then I know that I can write the corresponding adjoint operator with this B is the boundary conditions and B star is the corresponding boundary condition such that my bilinear concatenant is equal to 0. Then I know that I can find out the green functions. So, that green function I represent by G, and then I can find out the green function for the corresponding adjoint operator. Then what I want to find out the relation between G and G star, that what is the relation between the green function of the linear operator and what between the that G star, the green function of the corresponding adjoint operator. Now, we know that. So, I want to define that. Now, I also know that V of LU, the inner product, this is equal to L star VU. So, this is the way we have defined the inner product, and from there we are able to find what is the L star. And I also know from here that if L is equal to A naught d square by dx square plus A1 d by dx plus A2. So, this is my linear differential operator with some boundary condition that we represent by B. Then we are able to find my corresponding L star, the adjoint operator. So, that adjoint operator we can define as a naught x d square over dx square plus, then we have defined 2 times A naught dash minus A1, that is a function of x, d by dx plus A naught double dash minus A1 dash plus A2. So, that is the corresponding adjoint operator. So, from here we can find out the corresponding adjoint operator. Now, I know that so G is we are taking the green function for the operator L, then I know that L of G, so I call it x1. So, that is equal to the direct delta x minus x1. Then I define that L star of G star and that I represent by x2. So, this is x2. So, that is a direct delta defined at x2. Now, from here I will just try to find out what will happen to G star to L and then G x1 inner product. And I know that this will be again equal to taking the integration over the domain. So, the domain we are taking in this case the bounded domain we have taken, and that is between alpha and beta. So, this is from alpha and beta G star and then my differential operator, and that is G double dash A naught G double dash plus A1 G dash plus A2 G, and then the integration with respect to x. And now I can find out the solution for this one, and then we found that this will ultimately will lead to a alpha beta, and then it will go to L star G star into G dx. So, this is a function of x. So, actually this can be written as alpha beta L star G star, that is x x2, and this is G x x1 dx, and this one I can write as, so this we can write as is equal to L star G star and G x x1 inner product. So, from here we are able to write this one. So, from here I can say that G star L G inner product is equal to L star G star G this one. Now, I know that what is G star L G. So, L G is a direct delta function x minus x1, and this one is L star G star. So, this I know that is a direct delta function into G. So, this is the inner product. Now, if you see this one, now from here this one I can write as the integration. So, if I write the integration, this will be from alpha to beta G star is x x2 Dirac delta x minus x1 dx. So, this is my left hand side, and right hand side it will be alpha beta Dirac delta x minus x2 and then G x x1 dx. Now, by the property of the Dirac delta function, this integration on the left hand side will become G star x1 x2, and on the right hand side this will become G x2 x1. So, from here I can say that, so this is one we can write as that the G star, if I write it, so it is x and xi, that is equal to G of xi x. So, now this is the relation between the green function of the linear differential operator and the green function of its adjoint. You can see that if we are able to find the green function for the linear operator, then I just interchange the variable x and xi, and that should be the green function of the corresponding adjoint operator. So, this is called the symmetry property for the Green's functions of the linear differential operator and its adjoint operator. So, this one is we can write down. So, let us verify that how we are able to find the green function for the given operator and its adjoint operator. So, let us do one problem, then it will be more clear. So, let us take one example. So, let us solve the problem. L u is equal to u double dash minus 2 u dash minus 3 u, u at 0 is 0 and u at 1 is 0. So, this is the linear second order differential equation boundary value problem we are taking. Now, from here, so this is my, so my x belongs to 0 1. Now, I want to define what is my L star. So, if I want to find the L star for this one, then I know from here I can write down my V L u, the inner product. This one can be written as 0 to 1 and then V is a function. So, we know that V is a function, a continuous function which has the same characteristics as this u has. So, V is a function and then we are taking the inner product. So, it will be u dash minus 2 u dash minus 3 u and then taking the integration with respect to x. So, from here I take the write this integration 0 to 1, then V. So, it is V u double dash dx minus 2 times 0 to 1 V u dash dx minus 0 to 1 3 times V u dx. So, now I will try to solve this integration with by parts. So, from here if I apply this one, then this will becomes V u dash, taking the integration from 0 to 1 minus 0 to 1 V dash u dash dx minus 2 times. So, this one again I will solve this one with the by parts, then it will be again V integration of u dash, that is u 0 to 1 minus, then it will be V dash u dx and the last is this is same V u dx. So, this can be written again as this one. So, again I will solve this integration. So, this one is same as V u dash 0 and 1 and this one I can take here. So, minus 2 times V u 0 to 1 minus, now I want to integrate this one. So, this will be V dash u 0 to 1 minus, so V double dash u dx. So, this will be there minus 2 times we have taken. So, this one is there and then it will becomes plus 2 times 0 to 1 V dash u dx minus 3 times 0 to 1 V u dx. So, from here we can write further and then I can take this limits together. So, this will be V u dash minus 2 times V u minus V dash u 0 to 1 So, this one I have taken plus I can write it as 0 to 1 v dash u from here plus 2 times v dash u minus 3 v u dx. So, this is the corresponding the integration we are getting. Now, from here I know that u0 is 0 and u1 is 0. So, if I put the limit here and here, this will be 0 except only in this case. So, if I put this one, it will be v1 u dash 1 minus v 0 u dash 0. So, I will left with only this one plus, and this one I can write as 0 to 1 v double dash plus 2 v dash minus 2 v u dx. So, this is my bilinear concomitant. So, this is I can write as G, this one. Now, to define my adjoint operator. So, from here just to make this bilinear form equal to 0, from here I will define that if I am able to take my v 0 as 0 and v 1 as 0. So, in this case just to make it little bit more complicated, I can take this as u dash 1 equal to 0, and if I take u dash 1 equal to 0, then from here this will u dash 1 equal to 0 and u at 1 will not define. So, let us this one. So, I will just rewrite this part. So, from here I will write v 1 u dash 1 minus v 0 u dash 0. So, this is the first part minus 2 times v 1 u 1 minus v 0 u 0 minus v dash 1 u 1 minus v dash 0 u 0. So, this is I will getting from here. So, this is my bilinear form. So, to make this one equal to 0, now just try to do this one. Now, this part is given to me that this is 0, u dash 0 I do not know, my u 0 is 0. So, this is 0, this is 0. So, from here if I put these values, so u dash 1 is also 0, I will left with only this part. So, I will get from here that minus v 0 u dash 0 minus 2 times v 1 u 1 and minus v dash 1 u 1. u 1. So, this is my factor plus, and this one I can write as a L star v u, that is the inner product. So, this is my bilinear form. So, bilinear form u v. So, just to make equal to 0, then what I choose is that v 0 I will choose as 0. So, if I choose v 0 equal to 0, from here this will be 0, and then from here I will choose that 2 times V1 U1 plus V dash 1 U1 equal to 0, and U1 is taking common. So, from here I will get 2 V1 plus V dash 1 equal to 0. We are assuming that the U1 is not equal to 0, because we are given that U dash 1 equal to 0. So, from here we will get this value. So, this is my, so from here I will get my corresponding adjoint operator. So, the adjoint operator for this one is, in this case, my L star will be V double dash plus 2 V dash minus 3 V. So, plus 2 V dash minus 3 V. So, that is my corresponding adjoint operator. So, from here and my B star, that the boundary condition is that the V1 is 0, V0 is 0, and 2 V1 plus V dash 1, that is equal to 0. So, this is my corresponding boundary conditions. Now, we want to find out what will be the Green's functions. So, let us start finding the Green's function for the given equation. So, Green's functions for the given differential equation. So, we have started with this equation. So, that is my LU U double dash minus 2 U dash minus 3 U, and with the condition that U0 is 0 and U dash 1 is 0. So, from here if I want to find the Green functions, then if you see this one, so we know that L of G x minus xi. So, this is, I can say from here that L of G x xi is equal to 0 when x is not equal to xi. So, from here I can find my relation that G x xi I can find for corresponding homogeneous part. Now, I know that my LU is equal to 0 gives me U double dash minus 2 U dash minus 3 U equal to 0. So, from here corresponding characteristic equation will become lambda square minus 2 lambda minus 3 equal to 0. So, from here the lambda, the value of the lambda comes minus 1. So, if I want to factorize this one, this will gives me lambda plus 1 lambda minus 3 equal to 0. So, from here this is lambda square minus 3 lambda plus lambda minus 2 lambda and minus 3. So, from here I can find out my Green functions. So, Green function in this case will be, I can find out my Green function x I. So, this can be written as C1 e minus x plus C2 e 3x when x is less than xi, and D1 e minus x plus D2 e 3x when x is greater than xi. So, this is the Green functions corresponding to the given equation, and from here I want to find the value of C1, C2 and D1, D2. So, I know that my G of 0 xi, that is given to me So, this is given to me u0 that is equal to 0. So, from here I can find my C1 E0 plus C2 E0 that is equal to 0. So, from here I can find out my C2 is minus C1. Also, g of x at 1 xi, so this one will be equal to the given condition. So, from here I can find out that minus d1 e minus 1 taking the derivative of this plus 3 times d2 e 3 equal to 0. So, from here I can write down that minus d1 over e plus 3 d2 e3 equal to 0. So, that gives me my minus d1 plus 3 d2 e raised to power 4 equal to 0. So, from here I can find that my d2 will become, so I can take the d1 here 3 times by e raised to power 4. So, this will be 3 times e raised to power minus 4 d1. So, that will my value of d2. So, after inserting this value in the given equation, so from here I can write down that my green function will reduce to will become, so C2 is this one. So, from here I can write down my C1 will be C1 e minus x minus e 3x when x is less than xi, and this one I can as a d1 e minus x and d2 is this one. So, plus 3 times e raised to power minus 4 into e 3x when x is greater than xi. So, this is the green functions we are able to find. Now, I have two constants to find out, so C1 and C2. So, this one we can find out with the help of the properties of the green functions. That first thing is that g, the green function is continuous at x equal to xi. So, from here I can write down that the C1 e minus xi minus e 3 xi, this is equal to d1 e minus xi plus 3 e 3 xi minus 4. So, this one we can find out. So, this I can take as equation number 1. So, from here I can write down now, because I have a two constants C1 and D1. So, I need two equations to find out. Then we find apply the another properties of the green function, that del g by del x at x greater than xi jump discontinuity at x equal to xi. So, del g by del x at x less than xi, and it has a jump at of width that is 1 at x equal to xi. So, from here I can find out so x is greater than xi. So, this one I can find out d1 minus e minus xi plus 3 into 3 9. So, this one I can find out. So, my d2 will be 1 by 3. So, this should be 3 instead of this one. because this will go down and then it will be 1 by 3. Okay. So, this will be from here, if I change this one, it becomes 1 by 3, and then I can change this also. So, this will be 3 times into 1 by 3, right. So, this is the continuity condition, this one. So, this is putting the continuity condition, and then we are putting on this one. So, this will become d1 minus of this and E 3 xi minus 4, because I am taking the derivative of this one. So, 3 will be coming here and it will be cancel out this one. So, this value minus C1, and then putting the taking the derivative of this one. So, it will be minus e raised to power minus xi minus 3 times e raised to power 3 xi. Its value should be equal to 1. So, if I solve these two equations, and then if we do some calculation, so from here I can write my values of C1 and D1. So, if we solve these equations together, then after solving this one, I will get the value of C1. So, this one I can write directly. So, C1 becomes E minus xi plus 1 by 3 e raised to power 3 xi minus 4 into 3 by 4 e raised to power minus 2 xi divided by 3 plus e minus 4. So, this is the value of C1 we can find out, and then my D1 will be e raised to power minus xi minus e raised to power minus 3 xi into 3 by 4 e raised to power minus 2 xi, and then 3 plus e minus 4. So, this is the value of C1 and C2. So, from here I can write down my green function. So, I can the green function g x xi in this case will be, it can be written as so, I can write this as the final green function. So, this is 3 by 4 e raised to power minus 2 xi divided by 3 plus e raised to power minus 4, and then e raised to power minus x minus e raised to power 3x into e raised to power minus xi plus 1 by 3 e raised to power 3 xi minus 4. So, this is when x is less than xi, and 3 by 4 e raised to power minus 2 xi 3 plus e raised to power minus 4, this one, and then it will be e raised to power minus xi minus e raised to power 3 xi, and then it will be e raised to power minus x plus 1 by 3 e raised to power 3x minus 4 when x is greater than xi. So, this is the green functions we are getting for the given differential operator. Now, we want to find out the green functions for the corresponding adjoint operator. So, if I do the calculation, my L star will be, so L star V L star Vx in this case is V double dash minus 2 V dash minus 3. So, this is the differential equation we got. So, this is so after solving this one, this is my 3 V with the boundary condition V 0 is equal to 0 and v dash 1 plus 2 times v 1 is equal to 0. So, this is the adjoint operator we found out, and from here I want to find what is the green function. So, I know that the L star and the G, so I represent by star here. So, this is equal to x minus psi. So, from here just to find out g psi, let us solve this one, L star V x equal to 0. So, from here I will get my characteristic equation, that is the lambda square minus 2 lambda minus 3 equal to 0, and from here I can have the relation plus 3 equal to 0, because lambda square 3 lambda minus, so lambda square 3 lambda minus, so it should be plus here. So, this is plus sign, this is the plus sign. So, if I solve this one, then it is a plus 2 lambda and minus 3. So, from here I will get my lambda is equal to 1 and minus 3. So, my green function in this case will be C1 e raised to power x plus C2 e raised to power minus 3x when x is less than xi, and this is d1 ex plus d2 e minus 3x when x is greater than xi. Then I can find out the constants here. So, if I further solve this one, then I know that C, because the initial condition, the value at the V0 is 0 and this is the boundary condition at V1. So, V0 will give me C E0 plus C2 E0, that is equal to 0. So, again this give me C2 is equal to minus C1. So, this is the value at the 0, and then we also found that the V dash 1 plus 2 V1. So, that gives me, so I take the derivative of this one. So, this will be d1 E1 minus 3 d2 E minus 3. So, this is a V dash at 1 plus 2 times V at 1. So, it is d1 E plus 2 times d2 e raised to power minus 3 is equal to 0. So, putting this initial the boundary condition at 1 gives me this value. So, if I solve it further, then from here we can find the green function. So, from here I can write my green function g star x xi is equal to, so this will give me C1 e raised to power x minus e raised to power minus 3x when x is less than xi, and this will be d1 e raised to power x plus 3 times e raised to power 4 minus 3x when x is greater than xi. So, this is the green function, and then C1 and C2 again we can find out with the help of the properties of the green functions. So, from here if I apply the properties of the green function, then it will be C1 at E xi minus E minus 3 xi is equal to d1 E xi plus 3 times E 4 minus 3 xi. So, this is the first condition, the continuity condition, and the second one is that the derivative. So, from here if I write down, so it will be d1 E xi plus, so this is minus 3, so it will be minus 9 e to power 4 minus 3 xi minus C1 e xi minus, so it will be plus 3 e minus 3 xi, that is value equal to 1. So, from here if I solve it further and try to find the value of C1 C2. So, from here I will get the value of C1 is minus 3 by 4 e raised to power 2 xi over 1 plus 3 e raised to power minus 4 plus 4 into e xi plus 3 times e raised to power 4 minus 3 xi. So, this is value of C1 we got, and the D1 we can find out. So, the and value is coming 3 by 4 e raised to power 2 xi 1 plus 3 E4, and this is equal to E xi minus e raised to power minus 3 xi. So, from here I can find the value of G star. So, G star in this case will be x xi. So, if we write the G star, so G star will be 1 over 4 1 plus 3 e raised to power 4, this one. So, C1 is this one. So, it will be e minus 3x e x into 3 times e 4 minus xi plus e xi when x is less than xi, and this is equal to e raised to power minus xi minus e raised to power 3 xi 3 e 4 minus 3x plus Ex when x is greater than xi. And from here, so if you see, now in this case what I do is, I will try to find out what will the value of G star xi x, just changing the variables x and xi. Then from here I can write out this is 1 over 4 1 plus 3 e raised to power 4. So, in this case x is greater than xi, and if I put xi here, x here, so this will be this part. So, in this case I can write down e minus x minus e 3x 3 times e raised to power 4 minus 3x plus Ex when x is less than xi, and this will become e minus, so this will be x and this will be xi, and it should be e raised to minus 3 xi minus E3 xi 3 e 4 minus x plus Ex when x is greater than xi, and then it should be the same as the g value. So, e minus x minus 3x. So, if you see the g we found out, so this is the g we got e minus x here, and this is e minus xi 1 by 3 e raised to power 3 1 is xi. So, it should be same as that one. So, if we just do some calculation, we will get the value from here, and from here we can say that my G star x xi should be same as x xi. So, this is we are able to find the green functions for the linear operator and the adjoint operator. Now, what will happen if I take the self-adjoint operator? So, let us start with the the another form of the operator, and that is called the self-adjoint operator. So, self-adjoint operator, we know that when my L star, that is the adjoint operator, this is equal to the L itself, then we call it the self-adjoint operator. Self-adjoint operator. And now suppose we have the boundary condition also, B star is equal to B, and then we call it self-adjoint system. So, in this case what will happen? If I have a self-adjoint operator, then from here we can say that my G star, the corresponding green function of the L star, this will be G of xi, and this is by the relations from here, we know that from here I can write that the G x xi is equal to G xi x, because I know that for the green function of the adjoint operator and the operator, my G star x xi is equal to G of xi x. This is already we know from here. But when the operator is the self-adjoint, then my G star x xi will be G x xi. In that case, from here I can that the G x xi is equal to G I x. From this one we can say that for self-adjoint operator, then the green function is symmetric, that is my G of x xi is equal to same as G of xi x. So, this is true for the self-adjoint operator. So, in this lectures we have developed that how the adjoint operator we can define for the linear equation, linear differential operator, and then we found the Green's functions corresponding to the linear differential operator and its adjoint, and then we found the relation between the green function, that G star x xi is equal to Z xi x. And for the self-adjoint operator, we are able to show that the Green's functions are symmetric in nature. So, that is all in this lecture. Thanks for the watching.